Hey everyone, how's it going? See a few people jumping in. Sure, you hear my voice, I can hear. So can you see my slides?
Yeah, I can see you.
Nice.
I can hear you.
All right, we'll give it a couple minutes here as people wander in. Maybe we can do some quick intros or something along those lines before we jump in, just as people are wandering through. Um, sure, you want to kick off a quick intro and then I can go.
Yeah. Hi everyone, I'm Shri. I am an AI growth engineer here at Arise. I just recently started and just also graduated college, but that's pretty much my really short background. So yeah.
Awesome. And I'll throw in there too that Tree has been helping manage and run and like put together a lot of these paper readings now for a while. So for the folks who've been on a few of these, a lot of the material you've seen has come from her as well and come from some stuff here. So shout out to her for leading a lot of the paper reading prep and setup and everything that we've been doing. Yeah, from my side, for anyone who I haven't seen before or haven't met, my name's John. I'm leading up our developer relations org here at Arise. So get to do a lot of our some of our paper readings, some of our events, some of our kind of content, and a lot of our kind of technical external facing stuff that we do here at Arise. And these paper readings are always one of the more fun things we get to do because it's basically like licensed to deep dive into a random area of the world that we're interested in and then share it with a bunch of people. So excited to go through here. Um, I think we could probably get kicked off. We're a couple minutes in, so Shri, I'll let you jump in and kick things off.
Okay, awesome. Okay, so this week, we're just gonna be doing understanding modern AI benchmarks, and so we'll go through a couple different things that I have listed out, in like our little table of contents. But before I do that, actually, we have our Observe conference on June 25th. It's an all-day conference held at Shack 15 for all things observability related. So if you would like to come, we have a promo code right now for a $50 ticket, which is built with the Rise. And then if you scan that QR code, it will take you to our website where you can purchase those tickets. Or we're also still looking for speakers and also for people to present at our demo den. So if you're interested in any of that, all of the information is on that website if you would want to look into that.
And I would call it as well the community demo aspect of that, like the demo den that we do. We had some great demos last year. So if you've got a project or a thing that you've been working on within the AI space, definitely check out the demo den submission piece there because it's a fun way to kind of get to share that with a pretty big group of people.
Okay, so we have lots of things to discuss today, like I said. So, um, basically, we'll first talk about Gemini 2.5 was released sometime last week. My Twitter was very Studio Ghiblified, and so I feel like it wasn't given its moment. But we'll talk a little bit about that and just some relevant benchmarks that were being discussed like with the release of 2.5. And yeah, and just current benchmarks too.
And as always, if anyone has questions as we go through, feel free to drop them in the chat. I think we might have the QA enabled, so either the chat or the Q&A, and we'll try to tackle those as we go through. We're covering a few different topics here. It's all kind of, you'll see the story as we go through a little bit, but definitely don't hold your questions to the end. Feel free to drop them in the chat as we go. Cool.
Okay, so let's jump right in. So this is Gemini 2.5, Google's largest language model, and probably the most compatible version in the Gemini series so far. So it's kind of described as like a thinking model, which is just really about how it like will approach complex problems. So it's not like necessarily like generating fluent text. It's more like reasoning through tasks with more structure and more depth. So for context, like this is Google's answer to other models like OpenAI's GPT-4 or Anthropic's. Claude 3. All these models are kind of pushing forward on the front of like reasoning and long context understanding and like multimodal ability. So one of the core upgrades with this model specifically is in its reasoning. So it's everything from like the multi-step logic and like deductive thinking to having like the stronger mathematical encoding performance. So in benchmark testings itself, Gemini 2.5 Pro experimental. This is the first model within the 2.5 line. It shows like really consistent gains over previous models and like really competitive performance, like relative to GPT-4 and Claude 3. So one of the key features, like I mentioned, was the multimodal setup. So 2.5 can handle a bunch of different inputs and outputs like text, images, audio, video, and code. So this isn't like something super unique that we've seen. Like GPT-4 and Claude also kind of supports the same thing. But Google is kind of aiming, I think, for more seamless integration across like all of those platforms or formats. So for example, like Gemini can explain a chart or analyze a photo or like reason like over audio and video clips. So yeah, and then another big thing is that Gemini 2.5 also comes with an extended context window. So it's up to 1 million tokens in its experimentation form. So that's kind of like a broader trend of what we're seeing. Claude 3 can handle I think 200K tokens and GPT-4 Turbo supports I think 150 thousand tokens or something like that. So the longer context windows that we have, let's like the models handle full books or like legal documents or like really, really long conversations and like longer chain of thought threads without kind of losing track of what's happening.
Something interesting there too. I feel like we might start to see people eschewing RAG in some cases by just kind of increasing what they put into the context window. I think that's an area we can probably do a little bit of our own deep diving into at some point, is kind of comparing the accuracy and the success metrics of a RAG system to just we're adding more into the context window. If anyone has thought to try that out or has any experience background there, feel free to drop that in the chat as well too. I think that would be an interesting thing to spend a little bit more time diving into.
Yeah, definitely.
Next
So
slide.
yeah, next slide. So this actually is a chart that they published in their like release of Gemini 2.5. And so we can kind of see how it stacks up against like other like top models, like I said, like GPT 4.5, Claude, Grok, DeepSeek, so on and so on. And so some key points with this is that on the humanities last exam, Gemini is leading with an 18.8%. And usually we're used to seeing a lot higher percentages of like success with these benchmarks, but I'll get into that in just a second about why it's low, but it's still really good for what we've seen so far at least. And then just with STEM and coding, with like math and science, like the AIME, and stuff, like Gemini scores like at or pretty much near the top. So it's really competitive, honestly, in what we are looking at so far. And it's a pretty clear leader in the multimodal tasks like the MMMU and stuff. So while there's no one model that we're seeing like wins across everything so far. Like Gemini 2.5 is like really strong across the board, especially in like the reasoning math and multimodal stuff. So I think that's just interesting in itself. But yeah, this is what they published for us. And so yeah, so one of the benchmarks in particular that really stood out is the humanities last exam. So that's right at the top of the chart. Like I said, 18.8 might not look huge, but when you compare it with like everything else, it's a pretty meaningful lead. Most of the models are I feel like still trying to break the double digits. So, I mean, it is what it is. But okay, getting into what actually is humanities last exam. So, um, as like just in general, AI systems get more powerful, trying to figure out like what their abilities are has become a lot harder. And that's kind of where like benchmarks sort of come in. And a lot of the benchmarks are looking at things like just trivia puzzles or math problems with which like aren't really super encapsulating in how well a model is actually doing. And so that's when HLE really comes in. And it's kind of like a new kind of benchmark to test how well the models can reason, solve problems, and like most importantly, think like an expert. Um, and so the test is like it's like 3,000 questions or something over like over 100 fields in like a bunch of different subject areas. And so it's written by like real experts too from a variety of locations. And so it's just like a really encompassing test. It's not just comprehensive, but it's like really deeply built on like human experience and like the things that humans know. And so like the idea behind it is to push past just like the surface level smarts and to see if like models can really become an expert in every single one of these like subject knowledge, like subject areas. So it's not like necessarily about like memorizing straight facts and like trying to put them together, but it's about like, is it able to make those connections that we are able to if we were an expert in that particular field. Um, so yeah, it's like really important because we're trying to build systems that can handle like the real world complexity. So the wild part is that no one is really doing that great. Like GPT 4.0, I think scored like 3% or something. I have it on the next slide too. But it's just so Gemini 2.5 by comparison is kind of ahead of the pack. ChatGPT deep research is at 26%, I think, which I is a little bit higher than Gemini, but these two are kind of like the leading in the group. And the gap between like how good these models seem in demo and how they really do on an exam like tells us that there's kind of still a lot of work in these models themselves, but they're getting better as we kind of go along. Um, so yeah, I would kind of say that HLE is becoming almost like a North Star, like something to reach when it comes to making sure that we're focusing on like the deeper, meaningful capabilities. Um, I don't know if is that a hot take? I don't know if that's like per se a hot take.
I think, well, I think we're going to get into two variations on the thought process as we keep going. So that I think is one of the two thoughts of like schools of thought of, hey, HLE is now this North Star that we have. I think we'll get into a little bit of, is that the correct North Star to work on, work towards as we keep going here as well too.
Yeah.
But yeah, I mean, one thing I would like kind of double highlight in the last slide here is just these are questions that are coming from experts in a lot of cases. So like if you look at the example here, this is not just a question that that anybody you pick off the street could solve. It's something that requires some either background knowledge or requires some expertise in a certain area. This is like a classics one, so you need to have some familiarity with Roman script and kind of understanding and be able to translate that. So with HLE, it's basically like, hey, these difficult tasks pulled from the top of different fields, or at least like kind of the top section of different fields with kind of graduate level knowledge or PhD level knowledge in some cases. So it's also not that big of a data set too of 3,000. It's kind of interesting to see that that's all we really need to have as a benchmark for at this point.
Yeah. And it's still not getting through all of them is the biggest part in that. But yeah, I think just in general, these types of questions are helping like not just like the developers themselves, but also like researchers and like other people to understand where the models are actually strong and like what subject knowledge like they're able to connect the dots in and like build that reasoning. Um, and where they're still kind of like falling short. Um, so yeah, I think it's definitely like raising the bar to some extent and like pushing the entire like field itself to focus on something that is a little bit deeper and not so much like you said like those surface level questions. Um so yeah, it's just like I feel like it's a really big step in the way that evaluation is like actually starting to matter too with like is it able to like put together different pieces of information in like a cohesive way to even answer a question that complex.
And they got a catchy name too, which I think is always good to help with these benchmarks.
Mhm.
They stay top of mind.
Yeah.
Cool.
And
Oh,
then yeah, this was just my last chart that like basically says the same thing that I've been saying of this is how the current models are performing. And you'll notice a pretty sharp drop off. So I don't know, like the big takeaway I feel like from this is kind of like even like the best models that we have, like as they keep coming out, like what is the best model is like definitely a hard question to like answer. Like, and no one can really answer it, I feel like. Um, but like all of them are still really far from like expert level performance knowledge. Um, so yeah, but Gemini 2.5 is definitely pushing the frontier a little bit and setting a little bit of a new standard and like very competitive with what we have seen so far, I would say.
Yeah. It's fun to see it come out and perform so well on this benchmark. And I mean, humanities last exam is still a relatively new benchmark. So I think we'll see that start to grow as we keep going.
Mhm.
Uh, cool. So for a little bit of background as well too, I know we're kind of have talked a little bit about Gemini 2.5 and humanities last exam. One thing that stuck out to us was that humanities last exam was the main kind of, or the number one metric that was used, or number one benchmark that was mentioned in the Gemini 2.5 release. So that was kind of the impetus of us wanting to cover some of this benchmarking side of things. So that really jumped out to us as, hey, this is a top benchmark that's being used. So as a result of that, we kind of decided to go a little bit and back and kind of like look at some of the benchmarks that are being used. And I'm going to take some of the rest of the time that we have today to talk about some of those benchmarks and a little bit of my own thoughts and some of our own thoughts around whether those benchmarks are really indicative of real world tasks. So we're going to look at a little bit of that as we keep going through here in the remainder time. Um, so yeah, just a little bit like a popular benchmarks. We talked a little bit about humanities last exam. There's a bunch more. People have probably seen these. If you've read any of the announcements of models recently, you've definitely seen some of these names mentioned, but you typically have your different categories of kind of coding problems. Nowadays, we see more agent tool use or agent function calling benchmarks as well too with the past few releases. Reasoning, mathematics, some visual specific ones or some audio specific ones. And so you see a bunch of these different benchmarks being used. And I've starred a few of these. All of these, by the way, were mentioned in a recent, the Claude 3.7 release that they had, were mentioned all of these to some degree. So I've starred some of these. Shri, I don't know if you've seen the slides, but do you have a guess of what the stars mean in this case, if you haven't already seen the slide?
What the stars mean next to like the MMM.
Yeah, exactly.
Um, is it the ones that it does exceptionally well at per se?
Uh, Good guess, but not quite. If anyone's got them in the chat, feel free to drop them in as well too. I'll give you 10 seconds to do that. Um, I'm going to be surprised if anyone gets this kind of random, but basically the stars are all of the benchmarks that were mentioned and used in last year's GPT-4o announcement. So over a year ago when that announcement came out, all of the benchmarks that you see here with a star were used at that point. So kind of wanted to highlight that of, hey, there are some benchmarks that we're using that are more than a year old that are kind of hitting to a point where we may be starting to do pretty well on those benchmarks. So if you look at the Claude Sonnet 3.7 Sonnet release that was a few weeks ago, you can see all of the benchmarks that are being used here. It's a lot of the ones that we just looked at, like GPQA, for example, was used all the way back in GPT-4o. In some cases, these benchmarks are updated over time, but in some cases that we're using, for example, the AIME high school math set from 2024. So we are using these across a lot of different releases as we go through. And what you tend to see is if you take the model performance on those benchmarks and you kind of graph it over time, what I've got here is that the models on the x-axis are generally in chronological order of release. So this goes back a little ways, but you have models in chronological order of release, and then their performance on, in this case, MMLU, which was still is a very popular benchmark that gets used for general tasks. You can see models get better on these over time. Kind of makes sense as you think about that. Okay, obviously, as the models come out, they're going to get better on the benchmarks that we have. If you look at humanities last exam, that is already growing even faster. So that same kind of idea, just even starting with GPT-4o up to Gemini 2.5, you see that we're already kind of going from single digit percentages all the way up. It's increasing very quickly here. And sometimes you might see this and think, okay, we just get better models over time. Obviously, they're going to do better on the benchmarks. To me and to a few folks on the RISE side, we have debates about this all the time, but there's a question of, are we building towards a metric, or are models being built with metrics in mind, or are they being built to just generally perform well? And there's a good arts law, it's like a quote that is sort of relevant in these cases, which is when a measure becomes a target, it ceases to be a good measure. And so there is a question too of are we building towards just doing well on these benchmarks, or are we building models to be really just higher performing models overall? And I think the truth is probably a mix of the two, I would say. Like, I think there's probably these benchmarks being used as you go through and build a model, but I think there is just a general idea trying to improve the model's performance across a wide variety of tasks. But it is an interesting question to think about is, okay, Gemini 2.5 does way better on humanities last exam. Does that mean that it's just going to do that you're going to find it a better model over time and it's going to perform better as you use it in everyday tasks or in more difficult kind of tasks? So there is a question of do the benchmarks actually relate to real world performance? So something to think about whenever you're seeing these benchmark performances coming out. And with that in mind, we wanted to highlight one other one, which is ARC AGI 2. So there was an ARC AGI 1 that's been used for a little while now as a benchmark. But we wanted to talk about another one that got released, I think, last week as well, too. Should you correct me if that's wrong? I think it was last week.
Yeah.
So this is just another way of thinking about some of these benchmarks as well, which is that with ARC AGI 2, the idea is that it's supposed to target common weaknesses in existing models. And so some examples that they had were kind of symbolic interpretation, which we'll see an example of in a second, compositional reasoning, and then contextual rule application. We have a couple examples of each of these. You can find more on their site as well, too. But the idea here is that with ARC AGI 2, the tasks are things that should be easy for humans, but difficult for models. So you'll see in a second examples, but when you look at the benchmarks that they have on their site, when they have at least 2 humans look at a task, I think they have 100% success. So like these are things that are not meant to be super hard for people, but they're meant to be harder for models, which is an interesting kind of take when you compare this to GPQA or Humanities Last Exam, where you have these like graduate difficult level, graduate PhD difficulty level questions compared to, no, these are ones that like kids can do in a lot of cases from ARC AGI 2. So this is an example of one of those kinds of questions. I'll let people kind of look through this a little bit. I saw some stuff popping up in chat as well too. But yeah, so I think in this case, for example, you can kind of see they'll provide these 4 squares on the left and then ask a model to complete the side on the right there. And so in this case, I think people can probably figure this out if they go through it. It's like you're saying, okay, the things with a hole in them are green, the things with 2 holes are blue, and the things with 3 holes are red. And then you can see what the model needs to output from there. And so it's just like pattern matching that people can do if they just look at it for a second and kind of think through it. But models can really struggle with these kinds of tasks. And then they have a couple other examples as well, too. So they have another one here, which I'll let people look at a little bit, but it's basically like puzzle solving of shapes and how those shapes combine with each other and interact in that way, and how you can kind of combine them based on these like red dots that they have access to. So again, the idea here is these are things that are that's very easy to solve for humans, but very hard for models to solve. And when you look at the model performance on ARC AGI 2 or ARC AGI 1, you get GPT-4o with single-digit performance or even less in some cases. Like you get very poor performance. So it's kind of similar to Humanities Last Exam in the actual like numerical performance that you see, but very different kinds of questions. So the questions are much more like anybody could do it, any human could do it, just the models are not set up to think in that way, versus going down this route of saying, okay, the models are going to be really as good as an expert that we have. So it's kind of an interesting thought experiment here of, okay, are we building towards the right metrics? Are there certain metrics that are just hard to put together or to improve on as well too? Yeah. So. And I think there was one other chart that we wanted to highlight here as well, too, which is kind of the difference of ARC AGI 1 versus ARC AGI 2. As you're kind of seeing the scores across each of those, they also have you measure the cost per task. So there's an element of efficiency with this as well. So you can see, like in this case, the top left here is kind of where you go to win the prize. If you're trying, because they have a new monetary prize you can win if you can build a model that gets into that area. Nobody did it on ARC AGI 1, at least not that I know of. And so you can see even with things like chain of thought or synthesis or so these different tools with O1 Pro and O3, you're kind of increasing your cost per task over time, even as you can increase your performance. And then even going from ARC AGI 1 down to ARC AGI 2, you can see that, for example, in this case, O1 Pro or O3 using chain of thought and synthesis are already doing kind of much worse on ARC AGI too. So they've increased the difficulty of that as they go through. But yeah, so kind of an interesting thought experiment to think through is when we set up metrics, do we target them to be difficult questions that humans would struggle with that models can help us with? Or should we try to be targeting these models to improve on their base human capabilities to kind of make sure that they can do the baseline pattern recognition that we can do in certain areas? And again, I think it's always one of those things that comes down to the answer is probably a little bit of both, but it is interesting to think about how the different metrics are structured and the different benchmarks are structured as we have these models coming out. So we threw up a couple key takeaways as we go through here. I saw a few things in the chat as well too, so just want to cover off on those. So some notes about Gemini 2.5 Pro being a good co-pilot for tooling. So it's good for pair programming. Folks haven't really tried it with the RAG side of things as well yet. Yeah, I haven't actually switched like Cursor or my IDE to use Gemini 2.5, but I'll have to try that out and see. Sri, I don't know if you've had a chance to play around with it at all for
Haven't
coding.
either. But I'm interested to see how it will shape up.
Definitely.
Yeah.
And then there's another note as well too that the small increase in model performance or a grand announcement that has the sort of 0.3 improvement on a benchmark doesn't necessarily mean that the world has changed or there's some kind of crazy step forward. And at the end of the day, it's sort of incremental improvement that we're seeing, and it may not even equate to real world performance. Matt, let me know if I've summarized that incorrectly, but I kind of totally agree with the sentiment there as well. And there's a question, which is, which are the good benchmarks for safety, ethics, and scheming? So Apollo research. A couple that come to mind there. I think when it comes to kind of scheming and planning, there's a few benchmarks that are present around there. Even some ones that we actually touched on as well too. I think if we go back, there's a few that fall into the kind of planning side of things. Let's see if we include them here. I don't know if we actually included them in the visuals that we had, but I think there was one that jumped out to me. Either way, there are benchmarks that are used for kind of planning and kind of that route as well too. So there's a few of those that are kind of common that you'll see. I don't remember any offhand here, unfortunately, but for safety, which is an interesting one, the place that I would look there is actually, I think it was the GPT maybe 4.5 announcement. There was a recent GPT model announcement. It could have been one of the O1 or O3s. We can find it and share it in the community Slack afterwards. But they actually had a whole section on kind of safety as well in the model responses, which was something that it's not in every announcement. It hasn't been in that many of them, but they did have a whole benchmarking section around safety. So we'll find that and drop it in the community Slack as well as we go through too. Awesome. And then there's a question about how is NVIDIA thinking through this space? It's a good question. So I think in this case, the way I'm kind of hearing that is, okay, you've got NVIDIA who's working on the hardware side of things. How much are they thinking about model performance? And it's related to that. I know NVIDIA also has some of their own models. So there's probably the side of NVIDIA that's building their own models that's thinking a little bit more about this in the same way that OpenAI or Anthropic or whoever would be. I think from like the hardware side of things, I'm not entirely sure. I think my guess would be that they're probably not thinking too much about like model performance per se. I think they're probably looking much more at metrics around tokens per second or kind of the throughput that's enabled by the hardware that they have, and even the lower level metrics of like kind of decoder speed, encoder speed, like the kind of like sort of baseline level transforms that get to be made to just enable the models to run quickly, especially as you see kind of Grok or Together or some of these partners that are coming through with their own chip architecture as well too. So I think they're probably thinking more about like the hardware specific metrics there and less about the quality of model response. But it would be interesting to look at some of these numbers as well too across different hardware that the models are being run on. I think that would be an interesting thing to see. Look at the HLE performance and see if the same model run on NVIDIA versus AMD hardware, for example, has a big difference there. That would be kind of a cool thing we could do more research into. Yeah. Awesome. I think all we have. We're right at our 30-minute mark as well too. I don't know if there's any other questions that folks have. Feel free to drop them in with our last minute that we have. Otherwise, Maggie just threw a link in to join our community Slack. So if you're not already in there, please jump in, check it out. We'll share some of the links that we just mentioned here as well too in the community Slack wrap up afterwards. But yeah, Sri, any closing words for us before we hop off here?
Not quite. The recording will probably be sent later if you want to rewatch this or send this to anyone. Then we could also put the slides in the channel if you guys want access. But otherwise, we'll have another paper reading in about 2 weeks. So look out for any emails or messages in that community Slack, or our paper readings page on our website for more information on that one too.
Awesome. Awesome. Thanks, everybody. I appreciate all the questions and all the attention. Have a great rest of your day.